Yeah, so we're basically, so we got someone running from a farmhouse at some angle to the road, or to this vertical, trying to get to the road, okay? And the point of what Claire is doing is she's trying to catch a bus, okay? And this bus is just going along the road at 15 meters per second. Claire's going at 4 meters per second. So if you keep this story in mind, I think it will really help you realize what's going on later on as well. Okay, and I guess they're trying to meet at a point P where Claire gets on the bus, right? But obviously she can also get to the road before the bus gets there and then just wait for the bus, so that's okay too. Anyway, so Claire's trying to get the bus. The bus is just, he's not trying anything, it's basically obeying the laws of inertia. Okay, so to know how long it takes for Claire to come down here and how long it takes for the bus to come to this point relative to theta, that's the first question. Okay, and then it obviously just depends on knowing the distance. Because you know the speed, if you know the distance, then you know the time. Okay, same with here. You know this distance is 2,000. If you just know this distance, you know the whole distance. So, so for example, this distance here, we call this x and that y, right? So some simple trigonometry will tell you that x over 250 is equal to 10 theta. Yeah? And then you have 250 over y is equal to cosine theta. Yeah? Yeah, so if we just wanted to work out the time in terms of x, it would be 2,000 plus x. That's the distance, right? And then divided by the speed, 15. And as long as those are in meters, this is in meters per second, the answer will be in seconds. Okay, but we don't want it in terms of x. We want it in terms of theta. So we replace x by 250 times 10. This is equal to 2,000 plus 250 tan theta divided by 15. Okay. And I think you would get the 1 mark. This was worth 2 marks, so you get probably 1 mark for each. And you probably get the 1 mark just for this. But if you wanted to, you could also cancel out the 5. There's a common factor of 5 here. So that's 400 plus 5, 50 tan theta, 3. Yeah. And since it's the first part of a 2-part question, this might be useful. Okay, the other one is just simply y over 4, right? But y is 250 over cosine theta. So y equals 250 over cosine theta. So we got that from here, okay? And then, so this is the time taken is y over 4. So it's just 250 over cosine theta and over 4 again, okay? Which is the same as putting 4 here. And 250 divided by 4, well, that's 62 and a half. So it doesn't quite divide evenly. You get right 125 over 2 cos theta. And then this will be in seconds. Okay. So this is the first part of a 2-part question. We haven't read the second part yet, but you can kind of guess what it's going to be, right? You want to find the values of theta, because you're basically choosing an angle to run for the bus, right? You want to find the values of theta for which you can make the bus. So to make the bus, the time that you take has to be less than the time the bus takes to get to the point P, right? So we kind of have an idea what we're going to do. But yeah, well, let's read part 2 anyway, okay? See what part 2 is asking.